Let us go for solving problems on current electricity. Let me make a list of standard formulae which is useful to work out the problems at the ease. I have taken some list of formulae. The first one is R equals rho into L by A. That is, resistance of the conductor is directly proportional to its length and inversely to area of cross section, where this rho is called as proportionality constant. It is known as resistivity or specific resistance of the conductor. So this resistance is a function of these three, the right hand side. And we have one current in the conductor is drift velocity into electron charge into number of electrons in unit volume and area of cross section of the conductor. This is A. And next formula that alpha stands for thermal coefficient of resistance. What is meant by thermal coefficient of resistance? It is the rate of change of resistance of a conductor with the temperature. Delta R by delta T, rate of change of resistance of a conductor with temperature with a reference value R1 resistance. That is delta R. It can be written as R2 minus R1, and delta T can be written as T2 minus T1. So it is rewritten as this, where R1 is the resistance of the conductor when the temperature is T1, and R2 resistance of the same conductor when the temperature is T2. This R1 is remains same, and alpha is the temperature coefficient of the resistance. So let us work out the problems on this formula. The first problem is, if L equals 2L, find the new resistance. What does it mean? The problem: there is a metallic wire. It is stretched to double its length. The metal wire is stretched to increase the length by 2L. If that happens, what would be the resistance? Will it remain same or change? Look at this equation. R is a function of length. Definitely it change. Resistance is a function of length of the conductor. So let us solve this problem. As you know, all metal wires are solid. Let us change the shape of the solid. If the shape of the solid, the change in shape appears in the form of variation of its length and area of cross section. If we change the shape either by stretching or compressing, the change will appear in the form of variation of its length and area of cross section. So that is the one. On that concept, the problem is given, but its volume remains same. When you stretch or compress, the volume remains same, only length and area of cross section changes. So that is what, if L is equal to 2L, what could be the possible area of cross section, the change in the area of cross section? Look here, volume equation. Volume of a material, whether solid or gas or liquid, it is a solid. equals area into cross section. You can write this formula, area into cross section. That is area into length. So this volume remains same. In this problem, if L changes to 2L, what would be the possible change in A? Only when A equals A by 2, then volume remains same. Because you can give a proof like that. V is equal to, if L equals 2L and A equals A by 2, 2 cancel, we get back A into L. That is V A into L. If this is case, there is volume remains same. It means any change in the, that is that length is change the area of cross section. It increases, it reduces in this way accordingly. So use this, that is if L equals 2L, what is A? A equals A by 2. So you write this into the equation. Write the equation, or resistance of the conductor is equal to resistivity, it remains same when there is stretch or compressed, same material, L by A. That is, what is the new resistance? Upon changing this 2L, L into 2L, A becomes A by 2. Simplify, it becomes, that is, R dash is equal to, here A by 2 means it is 2 goes numerator, 4R, that is A by L. Rho into L by A. So rho into L by A is R. So R dash is equal to 4 into R. It means the new resistance, the resistance after the change, when you stretch it, it is increased by 4-fold, 4 into R. So this is how we can calculate problems like this. And the second problem is, this is stretching. Let us compress the conductor. If the wire is compressed to half of its length, exactly half of the length of the initial length, what is it? New resistance. Use the same concept because volume remains same. V is equal to A into L. See that if L equals L by 2, if L equals L by 2, what is the possible value of A? It should be 2A. In that way, 2 cancel, we get back A into L because volume remains same. So when L is L by 2, A equals 2A. So write this L and A into the equation. So this is what is that resistance at the initial state. Resistance at the final state is R dash is equal to rho into, this remains L becomes L by 2, A becomes 2A. Simplify, it is 1 by 4 rho into L by A. This rho into L by A is R. So R dash is equal to 1 by 4 R. Resistance, what is the name? Resistance. Resistance after compressing, what happens? Resistance reduces to, in this case, 1/4 of the original. So this is how the problems like this we can calculate using this technique. And on the basis of this mathematical concept, we can give the generalized formula, that is R dash is equal to N square R. On the basis of this mathematics, we can have this equation, standard equation. It is easy, it is better to have this equation. What is R dash? So it is a resistance after the change. What is the change? Length variation. It is increase or decrease by n times. So n means number of times the length. It refers to the length only. How many times the length change? Whether it is by 2 times or 1 by 2 times, it is increase or decrease. Number of times the length either increase or decrease. Here it becomes n square. R dash equal to n square into R. You apply this. If it is 2, you get this. If it is 1 by 2, you get this. So like that, for any value of n, we can have this resistance, new resistance after the change. We get this is a resistance, n square R. So on this equation, let us go for what is that a problem like this. There is a metallic wire, resistance is 3 ohm. If the L is equal to 10L, that means the metallic wire, the wire is stretched into 10 times its initial length. If that is the case, what is the resistance of that wire after the change? Directly you can straight away you can use this. R dash is equal to L square R. That is a resistance, initial resistance is 3 ohm and N is 10. 10 square. Simplify 100 into 3 is 300 ohm. Imagine that, just looking at this value. Here 3 ohm, when you stretch into 10 times, resistance increase to what is that 300 ohm. That is 100 times more than that. 300 ohms. So these are the problems you can expect, and it is based on electric toaster. So as you know, electric toaster is a home appliance where the heating element is a major component inside. What is that heating element? Is an alloy that is high resistance. There are so many alloys are there. One such alloy is nickel chrome alloy. Is it a nickel chrome alloy? Upon passing electric current through that resistance or resistor, what happens? The heat is liberated because the power dissipation takes place. I told you that power is dissipated upon passing electric current through any resistor. So because of power dissipation, electric energy change into heat energy, temperature rises. So these are the what is the conductors in which on passing electric current, temperature increases and resistance also changes. So on that basis the problem is set. Here electric toaster, this is one is heating element, and resistance of that material is given at this temperature because resistance and temperature are function. Resistance is variable with temperature. Resistance of that is at temperature is 27 degrees centigrade and 27 degrees centigrade. Now this toaster or to this resistor, if you apply 230 volt, that is connected to, usually 230 volt is the voltage at the residential buildings. 230 volt current passes. While current is passing, temperature increases. Current and temperature are both variable, increases as the current increases. Now finally we are finding what is at a constant value of current, a steady value of current attains after some time, after a few seconds or few minutes. So that steady current is 2.68 amp. The voltage is this, the current is this. To the toaster or to this resistor inside. What they have calculated, what is the temperature after attaining this steady state? That is steady temperature. Calculate. You are given alpha value. What is alpha? Temperature coefficient of this alloy, nickel chrome, is given this value. Degree per coulomb. That is one. So for this one we have to use this equation. That is our temperature coefficient of resistance. So let us call this as R1. This as R1 at temperature, resistance corresponding temperature. You have to calculate resistance. Second, there is resistance is not given, and temperature. Resistance and temperature, that final state. But instead of resistance, you are given voltage and current. That is, you know that voltage and current V is equal to IR. If you know V and I, R can be calculated. Resistance of that conductor can be calculated. That is why after attaining the steady current with this voltage and current, resistance is, look at the resistance, increases. It initially was this, it is increased to this value. So that resistance is this. What would be the temperature? For that use the equation. This is the equation 1. So it is written in what is written in the inverted form. T2 minus, same thing as rewritten as Q2 minus Q is equal to, that is R2 minus R, alpha into R1. You have to calculate T2. T2 means temperature after attaining this resistance. T2 to be calculated, and T1. Let us the initial, that is T1 is this one. These two as taken as R1 and T2. This is that is 27 degree upwards. That is R2 is this, R1 is this, and this value is given. Alpha value of the nickel chrome is given, and R1 is this. The same as simplify this, we get this value. That is T2 minus T1. So T2 is equal to this plus this. What is T1? This 1 degree. So 847 degree. T2 is equal to 847 degrees centigrade. So initially, before passing current or little current while passing, the temperature was around 27 degree. After attaining the steady, what is the current of this? The temperature, look at that, is increased to this value, 847 degrees centigrade, because it characterizes that it is a nickel chrome. That is the value. This what is the thermal coefficient of this value is this. So this is a problem. Practically we are using this as a problem as well. And one more problem is also using the put the materials in the practical use. So nowadays we are using that is a platinum thermometers. The reason platinum, the resistance is a temperature variable. Resistance and temperature of platinum are both are variable. On that concept, we are using platinum as a thermometer, platinum resistance thermometers. So on this concept, it is problem is set. Here given here, the resistance of the platinum wire is 5 ohm at this temperature. What is the temperature? Ice temperature. Ice temperature is 0 degree. And resistance of the same platinum is this value. At this temperature, it is 100. It is steam temperature. 100 degree centigrade. These set of values are given. And one more, that is when temperature, that is when this thermometer is inserted in hot bath, it is higher temperature bath, its resistance value is this, increased to this value. What would be the possible temperature of this bath? That you have to calculate. So write this equation, but alpha is not given for the platinum. Alpha is a must. First we can calculate alpha for this set of data, because we know all these things. Same equation, what is that? This equation can be used. It is alpha is equal to, write this as equation, this divided by this. So R1, R2 substitute and T1, T2 substitute for this. Substitution is done. Here T2 minus 100 minus 0. This simplify, you get that is minus this is 5 into 100. This is the alpha value. Keep it as it is, don't simplify. This is alpha value of the platinum. And next is using the same equation, calculate what is T2. That is, you can write in same equation, you can write it as. Now you can take T2 and R2, and T1 R1 as this, any one of them, either this or this. You can take this R1 R2. So R2 is this resistance is given, and that is R1 is this, then temperature is given 0, and alpha what we calculate this into, again R1 is 5. Simplify, this 5 cancels, finally we have this equation, and T2 equals 345.65 degree. That is T2 minus 0, T1 is 0, is T2 only. So final temperature, what is that? The temperature of that bath, hot water bath, is 345 degrees centigrade. This is how, that is indication. Thermometers always what is the resistance and the temperature are indicated. The variation of resistance, temperature is indicated on the thermometer. We are using on that concept. And finally we have equation, it is based on this only. Here you have to calculate what is the resistance of the metallic wire. Metallic wire mass is mentioned and its resistivity value is given, density is given, and area of cross section is given. That is, the metallic wire is blown into a wire of what is the area of cross section, this value, of course in millimeter square. That is the one. So you have to use the equation R is equal to rho into L by A. So in this equation, this is given directly, of course. A is equal to 0.05 millimeter square. You have to change it into SI unit. Millimeter means 10 to the power of minus 8 is m whole square. Whole square meter it becomes in SI. 10 to the power of point, this becomes 5 10 to the power of minus 8 square meter. First you have to convert this into SI unit. Area of cross section. This is given, but L is not given directly. Then what else you can go for? Density is given. Write the definition for density. Density is equal to mass by volume. Whether solid or liquid or gas. Mass by volume. And here in the volume, you can write the volume of the material as area into L. Because I want value of L. So D is equal to mass into A into L. So what is L now? L is equal to M into A into D. Then L in the form of mass of the material and density of the material and area of cross section, because all these values are given in this case. Indirectly it is mentioned. So write this value, write this into this equation, you get this equation. Rho into L is this into 1 by A. So what is mass? Milligram. Convert into SI. SI is kg. Milli means 10 to the power minus 3, gram and again kg. 10 to the power minus 6 kg milligrams. This is overall 10 to the power minus 4 kg mass. So this mass is this. And area is this. Substitute for them. This is given. Rho is this value, given value, and M is this, and A is, that is the one we have calculated, this is A, and D is density is given. Density is in SI only, kg per meter cube in SI. So directly write this value into again A. Simplify, you get this value 10 to the power of 3. Again simplify, you get 5.714 ohm. That is the resistance of the material with this data calculation. So with this you can finish with this set of problems. Let us continue the next class for some problems.